In this video, we're going to continue with factoring polynomials part 2. We're going to focus on how to use the GCF. We'll first start by going over a quick review of what GCF stands for. When we're talking about the GCF, we're talking about the greatest common factor. This is where we have two or more numbers, and we want to divide all of these numbers by a same factor or a number that's smaller than the ones that we start with. Greatest means that we're looking for the largest possible option. So let's start with an example. What is the GCF of the number 56 and 72? To find this, we first break them down into a factor tree. We always start a factor tree with the number 1. If I divide 56 by 1, I get 56. If I divide 56 by 2, I get 28, and I continue moving until I have identified all of the possible factors of 56. And here they are. I do the same with the number 72. Now that I have identified all the factors of 56 and 72, I go through all of them and I circle the ones that they have in common. They both have a 2 in common. They both have a 4 in common. They both have an 8 in common. And looking a little bit more closely, that looks like all of the factors that they have in common. So the common factors are 2, 4, 8. The greatest common factor, meaning the biggest one that they have in common, is going to be the number 8. Let's look for a GCF of some variables. What would be the GCF of x squared and x to the power of 4? To find the GCF of these two, I'm going to write them in expanded form. Because we don't know the actual values of x, I can't make a factor tree, but writing them in expanded form does show me what they're made of. I can see that both of them have x's in common. The greatest number of x's they have in common is 2. They both have x squared. So that means that when we're working with variables and looking for the GCF, we're looking for the maximum amount of x's they have in common. In this case, they have 2 x's in common, so the GCF is x squared. Going back to the definition we learned in our last video, we are going to factor a polynomial, meaning divide it, using the GCF. And the key point here is that when we are factoring using GCF, the GCF has to work for all terms. So let's go back to the example that we did when we distributed a few videos ago. When we distributed, we are really multiplying through a polynomial. We take the term on the outside and we multiply by both terms on the inside. This gave us a polynomial with no brackets. It was fully distributed and simplified. Now what we want to do is we want to work backward, meaning we want to factor or divide so that we end up with a monomial in the front and a polynomial in brackets. This is where the GCF is going to come in handy. I want to divide both of my terms by the greatest common factor. This means I have to pay attention to two parts. I have to find what is the GCF of the number or the coefficient of each term, and what is the GCF of the variables for each of these terms. Again, when I'm looking for GCF, I'm looking for a term that works for both of these things. So what do 10 and 26 have in common? What would be their GCF? Well, the only number that they have in common is the number 2. Well, what do x squared and x have in common? Again, in this case, the number of x's they have in common is 1x. So that means my GCF, the total thing that I'm going to divide by, is 2x. Notice that's exactly what happened in the example above. Now that I have found my GCF, I write the GCF on the outside. That becomes the monomial on the outside of the brackets. And then I use dividing polynomial, what we learned in our last video, to help me simplify what goes into the brackets. 10 divided by 2 is 5. X squared over x is x. Minus 26 divided by 2 is 13. X divided by x is 1. And so I'm done. So what we're doing here is finding the GCF of a polynomial and rewriting it as a monomial times a polynomial, meaning we're working backwards to put our polynomial back into brackets. Let's take a look at a more complicated example. Here is a trinomial. I want to factor using GCF, which means I'm looking for the greatest common factors of all my coefficients, of all of my variables. So I'm going to start by looking at my coefficients. I have a 6, a 3, and a 21. What do all three of these numbers have in common? What common factor do they have? And again, I'm looking for the largest possible number that will go into all of them. So I can see that a 3 is my greatest common factor. So I'm going to divide all of them by 3. I can't choose a larger number because one of my coefficients is a 3, so I can't choose anything bigger. It's got to be smaller than what I started with. Then I take a look at each of the a's. In my first term, I have an a squared. In my second term, I have an a, and then an a to the fourth. What is the most a's I can pull out from all three of my terms? Well, the last one has 4 a's, the first one has 2 a's, but the middle one only has 1. So that means the maximum I can pull out from the a's is just a single a from all three terms. Remember, your GCF has to work for all of them. And again, I look at my b's. The first one has 3, the second one has 2, the third one has 1. That means the maximum I can pull out from all three terms is a single b. So in this case, my GCF ends up being 3ab. So we are choosing a GCF that pulls out the most possible factors from all three terms. My GCF becomes the monomial on the outside, and whatever's left over after I'm done dividing is what's left on the inside of the brackets. So let's begin. 6 over 3 is 2. A squared over a is a. B cubed over b gives me a b squared for my first term. Then in the second one, negative 3 over 3 is 1. A over a is 1. B squared over b is b. So 1 times b is just b. In my last term, I have 21 over 3, that's 7. A4, or a to the 4 over a is a cubed. And b over b is 1. So this ends up being my final answer. Here's another example. Why don't you give this a try? Start by finding the GCF of the coefficients, then the x's, and then the y's. Pause this video here. I'll give you a little hint. Notice that all of them have a negative sign in front. Remember to look at the exponents for each of the variables to see what they all have in common. After carefully observing each of the parts of my trinomial, I've determined that the GCF must be negative 4 x squared y squared. Now I simplify each of the terms to give me a final answer. In factored form, this is what my polynomial looks like. Don't forget that when we factor using the GCF, it doesn't go away. the GCF remains on the outside, and after we've simplified the polynomial, the remainder goes in the brackets. So we're not deleting this part, we're just factoring it out. Thank you for watching this video on factoring polynomials using the greatest common factor. Click on the next video to see how to factor trinomials into binomials.